Let's giggity go. Welcome back from Thanksgiving break. We are at the last video of the semester and almost the end of 2020. Let's go, people. Analyzing some functions here. As you can see in these first couple problems, we are looking at where the function is equal to 0, or some people would say that is the x-intercept. So where does it cross the x-axis? Where f of x is less than 0, or where is it below the x-axis? And then where the function f of x is greater than 0, where is it above the x-axis? And we're just looking at those intervals. All of these intervals are going to be written in notation, and they're going to be written in reference to your x values. All right, so it's basically what x value do I cross this red line or the x-axis? I don't. So that's why this is an empty set. That's just simply not happening. Then we have f of x is less than 0. Where is it below? So we see the function is below here in this beautifully highlighted green section here. And that's happening from negative infinity to 3. As you can see, the vertical asymptote. So that's going to be telling us where things are changing here. So as you can see that we see this 3 again, and that is where f of x is greater than 0, or where is it above the x-axis, and this is happening from x is 3 to infinity. As you see, we're using parentheses on all of these things. Next problem is going to be more of the same. So where does this hit the x-axis? X-intercept, this is happening at a value here at -2, so we just simply put that in. And then we have where is the solution less than 0, so we see it here in green again. It is happening between -2 and 0. And then where is it above the x-axis? And so this is happening from negative infinity all the way until we hit -2, and then we pop over here, and this is happening between 0 and positive infinity. Next problem, where do we hit the x-axis? Where is it equal to 0? That's happening at one value, that is 0. And then where is this below the x-axis or less than 0, as you can see in the screen section? So from -2, this vertical asymptote, into this other one at 2, so it's from -2 to 0. So we do have to cut it off here because it isn't less than, it's actually equal to it there. And so we have to write it like this. A little bit easier here, we're just filling in the blank. And then where is this thing above the x-axis? Now this horizontal asymptote here doesn't really matter. We're looking at where is it above the x-axis, so that doesn't really play into this, and then that is the interval there. Now we're solving these things and we're looking at common denominators here. So it's best if we factor out these bottoms. So as you can see, I've factored out this bottom here, so it's x times x minus 3. And these are a difference of 2 squares, so we have x plus 3 and x minus 3 times each other. So it's easier to see the factors. So I've written here in blue, this is what the common denominator is. So basically, when we're solving these types of things, we look at the denominator and we multiply the top by what it doesn't have. So as you can see down here, we are missing the x plus 3. That's what I'm multiplying here. That's how I distribute to get 3x plus 9 minus, and then here I am missing the x, and therefore I multiply the top by x, I get x. Now I just collect like terms and solve. Bada boom, bada bing. Moving on. More of the same here. We see our common denominator is x squared, so I'm multiplying this times x squared. I'm multiplying this one times x, and this one I don't multiply by anything because I already have the common denominator. And I end up with this quadratic equation, which you can use the quadratic formula to solve. We can factor like I did here. And one thing to watch out for are called extraneous solutions, meaning once we get to this part, we look and see, can I plug these values in? Meaning, if I plug them in, am I going to get 0 on the denominator? As you can see, if I plug in either one of these values, I'm safe, so they are both part of your solution. Next one, following the same, my common denominator is x squared. I multiply it out, I end up with this quadratic. I can't factor it, so I have to use the formula. And here, you could actually plug this in. You could type it in. You have a button for plus or minus, so you could actually type this in just as is. We're not able to, you might be able to, but mine was not able to simplify my, my radical, so I just left it as such. The next problem, we do have to worry about these handy-dandy extraneous solutions. So we're following suit here. My common denominator is z minus 1 times z plus 1. I just factored out these difference of 2 squares. Once again, we're multiplying by what the denominator doesn't have. And so I do that. As you can see, I put that into this equation here. And don't forget your minus sign there. And then once I do that, I see that I have something I can factor, or you can use the quadratic formula. And then here's when I solve that, I get 1. So if I plugged in 1 here, 1 minus 1 is 0. So that's why this is an extraneous solution and it is not included. So you're only going to be typing in -3. And then our last one, we're analyzing this graph here. We're looking at insect population. And so we see that we have the same exponents on top and bottom. So that means in order to look at a horizontal asymptote, we just simply divide the coefficients of those terms. And so 9 divided by 1 is 9. So that's where this y equal to 9 comes. All right, so we're looking at it's going to top off. There's only going to be so many insects. And then initial, meaning if I were to plug in 0, so initial is like when the time is 0 when we're first starting to look at this population. So you plug in 0, 9 times 0 is 0, plus 3 is 3. 0 plus 1 is 1. 3 divided by 1 is 3. But we're dealing in the millions, so make sure you write 3 million here. What happens to the population after several months? And so this is where we're kind of looking back at this horizontal asymptote. So that's what's happening here. This population is going to plateau at 9 million. So whatever this horizontal asymptote is going to be directly affecting that answer. And then basically, what is the definition of a horizontal asymptote? And that's what we have here. Population gets closer and closer to a certain size. We are done, people. Let's giggity go.